This conference will now be recorded.
So yesterday we did actually Oracle database server. Then in Oracle server we discuss about Oracle database instance and Oracle database and Oracle instance. We discuss SGA. Okay, in SGA we discuss shared pool, database buffer cache, redo log buffer, fix SCA, Java pool, stream pool, in memory, mem optimized pool, flashback buffer, and two other components, right? So today we will discuss about background processes. But before going to discuss background processes, can any tell me what is process actually? Yeah, guys, what is process? So process is basically a mechanism in operating system that can run a series of steps. So that step user will give you to the operating system actually. So process will perform these types of work. So in Unix or Linux we called as operating system process or a thread. Okay, but in Windows we called as a thread only. So this is the difference. And process normally run its in its own private memory area. So most processes can periodically write to an associated trace file. Okay, so this is the introduction of the process. Now, how many types of process we have in Oracle database? So basically, we had two types of process. One is client process, another one is Oracle process. Okay, and in Oracle process, we had three kind of process. One is server process, another one is background process, and next one is slave process. So this is the process things in the Oracle. So client process basically starts or enable when you run the application or when you execute Oracle tool code. And Oracle process is basically unit of execution that runs the Oracle database code. So Oracle process can be an operating system process or you can say thread. Okay, and Oracle process, as I said, are three types. One is server process, which performs actually client request. Whatever client is giving the request to the database, it comes in the form of packet, and that packet server process will receive, and whatever the statement is, according to that statement, server process will parse the query, check the things in the data dictionary and place them in shared pool, and create and execute a query plan for each query and read buffers from the database buffer cache or from disk. So this is the work of server process. Okay, and server process and the memory and the process memory allocated in this process run in the database instance. So the instance continue to function when server process terminate actually. And now second component is background process, which you are seeing on the my ppt. Background process basically start when you start the database instance, and it will perform the maintenance task, it will perform instance recovery, it will perform clean up things in the database, it will write the dirty buffer to the data file, it will write the redo buffer to the redo log file. So these are the work of background process, but that depends on the type of background process we have. So third one is slave process, which is basically additional process which help to the background process or server process. Clear, guys? So if you want to check about the process, so we had a query of v dollar process. So you can execute this query on your database and it will display about the process according to SPID. Okay, so it will display. And now come to when client process start, or what actually it how we can check that. So whenever a user run an application or SQL star plus, the operating system actually creates a client process. Sometime it is called as user process to run the user application, and then client application has Oracle database libraries basically linked into it that provide the API is required to communicate with the database. Okay, and Oracle process serving the client process can read from and write to the SDA, whereas the client process cannot. So client process can run on a host other than the database host, where Oracle process cannot be. Okay, so how you will check? So on client host, you can check by this command actually. So this will tell you about the client process. So here SQL show only, it will show only SQL client process. Okay, and if you execute this command on the database host, so it will display, it will show a server process with a connection type, whether it is a non-local or remotely. Okay, but no client process, you will get it on database side. Clear, guys? Now, what is connection and what is session? Please answer. Those who are working actually, what is connection and what is session? No one is answering. Okay, no issues. See, connection is basically a physical communication pathway between a client process and a database instance. So during a connection, communication pathway is established using whatever inter-process communication mechanism available or network software is available. Okay, typically connection occurs between a client process and a server process or a dispatcher process. Okay, so let me ask you another question. When server process will be available and when dispatcher will be available? Yesterday we did that. Yeah, guys. When we got server process, when we got dispatcher, yesterday we discussed that. Did you checking my session on YouTube, or you are making notes, something like that, or you are revising something? I don't think so, nobody is doing that. Okay, see, when you had a shared connection, then you will get the dispatcher process first. And when you have dedicated connection, on that time you will get server process. Okay, so it means when connection is dedicated, then you will get server process who will take the request. When you had shared server connection, then dispatcher process will come into the picture and it will take the request. Revise large pool. We discussed yesterday about how dispatcher work, response area, request area. You forget everything, guys. Okay, now session is basically a logical entity in the database instance memory that represent the state of a current user login to a database. Suppose user is authenticated by the database with the password. So session will be established for this user and this session will remain until the time the user disconnect or exit the database application. Okay, and single connection can have 0, 1 or more session. It depends. Okay, and the session are independent. So if suppose any commit in one session happen and it will not affect transaction in other session. Okay, so please remember this. So suppose you had a user HR, he can have multiple connection to a database. Okay, and as I said, in dedicated database server connection, the database creates a server process on behalf of each connection, and only the client process that causes the dedicated server to be created uses it. And in shared server, many client process access single shared server process. So in the diagram you see that first figure is showing dedicated connection where client is one, server process is one, session is one. Second user, client is one, server process is one, session is one. Now third is not a dedicated, it is a shared connection. So server process is sharing or doing the work for both sessions. Okay, so that I want to tell you. Okay, so you have the query v dollar session which you can execute and get the information about any particular user. So I'm posting those queries, you can note it. Maybe many people knows that, but I'm taking this session like as a fresher you guys are attending. Okay, now come to a server process. So when server process creates actually, guys, another question. Anyone? When authentication happens, okay. Anyone else? See, Oracle database creates server process to handle the request of client process connected to the instance. So client process always communicate with the database through a separate server process. So actually, server process creation depends on the connection method. So how many types of connection method we can use in Oracle database? The first one is Bequith. Okay. Second one is Oracle Net Listener. Okay. And the third one is, can anyone tell me? Yeah, guys. Dedicated broker. So these are the connection On the basis of that, your server process will create. Suppose your connection method is bequet, so SQL star plus and OCI client or another client application directly spawn the server process. Okay, when your connection is Oracle net listener, the client application connect to the database through a listener. And dedicated broker, this is a database process that creates actually server process. Unlike the listener, the broker resides within the database instance. When using a dedicated broker, the client connects to the listener, which then hands off the connection to the dedicated broker. So when a connection does not use bequet, the database creates the server process in this order. The first order is the client application requests a connection from the listener or broker. Second, the listener or broker initiates the creation of a new process or thread. Third, operating system creates the new process or thread. Fourth, Oracle database initialize various component and notification. And fifth, the database hand over the connection and connection specific code. So this is the order of database creates the server process like this. Okay, clear guys? Now come to background process. I hope server process and client process is clear you guys. So background process, as I said, additional process of Oracle database. It will perform maintenance tasks to operate the database and to maximize performance for multiple users. So if you want to check how many background process we have, so there is a query for that. So you this query you can execute and you will get the background process. And there are mandatory background process, there is a optional background process, and there is slave process. So these three things we will discuss now. So what are the mandatory background process we have in 19C? Guys, answer me. Tell me first how many numbers? Two, three, four, five, six. How many? Mandatory background process. Five. Okay. Five. I'm asking 19C Ajit. 11G gone. 12C gone. 18C gone. Now 19C is there. There. Array boss, mention my PPT, it is mentioned 10 background process we have. So what are those? PMON, ASMON, DBWR, LGWR, CKPT, MMON, MMNL, RECO, PMAN, LREG. Okay, so these are the mandatory background process, and optional process we have our archiver process, CJQ, that is job coordinator process, RVWR, FBDA, and SMCO, and slave process are dispatcher and shared server process. Okay, so mandatory background process. So first I will discuss uh, process monitor, that is PMON group. So actually this process, this group contains three processes. The first one is PMON, and second one is CLMN, that is cleanup main process. Third one is CLNN, so that is cleanup helper process. Okay, So these three process makes a group which is called as PMON group. So now what it will do? Earlier we know that PMON will do the listener registration. Okay, the first important task it was done till 11G, but after 11G it changed. So now tell me which process will do the listener registration from 12C onwards. Another question. A small? No, dear. Till 11G it was done by PMON, right? LREG, yes, perfect. So from 12C onward, LREG process introduced, and that is the process will do the listener registration in the database from 12C onward. Okay, correct. So now back to PMON group. So basically now these processes are responsible for monitoring and cleanup of other processes work. Okay, so PMON basically is responsible, PMON group actually responsible for clean up the buffer cache and release of the resources which is used by client process, and it will release the logs that are no longer required. It will remove the process ID of terminated process from the list of active process. It will resetting the status of the active transactional table. Okay, so the database must ensure that resources, whatever resources is held by terminated process are released, so they are usable by other process. Okay, so now PMON actually deduct the termination of other background process. If a server or dispatcher process terminates abnormally, then the PMON group is responsible for performing process recovery. Okay, so a PMON only deduct, and after that PMON tell to the CLMN process, that is cleanup main process. So the task of deducting abnormal termination remains with PMON. Then CLMN perform the cleanup of terminated process, terminated sessions, transaction, network connections, ideal session, detached transaction, and detached network connection that have exceeded their ideal timeout. Okay, but actual CLMN will not do. CLMN will tell to CLNN helper process. So actually, the work of this cleanup things will done by CLNN process. So the number of helper process is proportional to the amount of cleanup work to be done and the current efficiency of cleanup. Okay, so cleanup process can become blocked, so it prevents it from proceeding to clean up other process. So if multiple process require cleanup, then cleanup time can be significant. For this reason, Oracle database can use multiple helper process in parallel to perform cleanup. Okay, to avoid slow performance. So we had two view actually, which contains metadata about CLMN cleanup things. Okay, so you can check those views, that is v dollar cleanup underscore process and v dollar dead underscore cleanup views. Okay, so v dollar cleanup process contains one row for every cleanup process. Okay, clear? And also, as I said, PMON group release the held resources to the database. but in some cases pmon group can automatically quarantine corrupted unrecoverable resources so that database is not immediately forced to terminate. Okay, so that is the things you should remember. So there is a view v dollar quarantine view contains metadata such as types of resource, amount of memory consumed, oracle error which causing the quarantine, etc. Okay, so that view you can also check that. So please remember these view whatever I am telling and make it a note. Okay, clear. Now pmon is this. Okay, so now pmon is a thread or operating system process. Tell me guys. As I said, on Linux, you had operating system process, or you can say thread also. So Pmon will run as a thread or will run as a operating system process. Guys, excuse me. Pmon can run as an operating system process and not as a thread. Okay, so please remember that. Rajiv, you can remember. Okay, now next process is Pman. So first thing, pman will run as a operating system process and not as a thread. So remember this also. So what pman will do? So this is the new process actually, which oversees several background process including shared servers, pool server, and job queue process. So pman actually monitor, spawn, and stop the following types of process like dispatcher and shared server, connection broker and pool server process for database resident connection pool, job queue process, and restartable background process. Okay, so this is the work of pman. Clear guys? In the diagram it's mentioned. Okay, can pman run in asm instance as well? And also tell me pmon can also run in asm instance. Tell me guys. Yes, pmon and pman both can run on asm instance also. Okay, now come to lreg, which is a new process which introduced in 12c onward. So as I said before, 12C Pimon performed the listener registration, but now 12C onward, LREG, that is listener registration process, will register information about the database instance and the dispatcher process with the Oracle Net Listener. So whenever instance is start, LREG polls the listener to determine whether it is running or not. If the listener is running, then LREG passes the relevant parameters, or you can say information, to the listener. If listener is not running, then LREG periodically attempt to contact it. So that is the work of LREG. So now tell me, LREG run as a thread or an operating system? Yeah, guys. LREG run as a thread or process operating system process. LREG will run both, okay, and also LREG run on ASM instance also, and in rack also, okay. So remember this point. Now the another important and very old background process, which is SMON, system monitor process. So what actually it will do? System monitor process will perform instance recovery. It recover terminated transaction. It will clean up unused temporary segment. It will coalescing contiguous free extent within dictionary managed table space, and also SMON checks regularly to see whether it is needed by other process. So whenever other process can call SMON, so SMON will go and help them. Okay, clear? And SMON is also run as a thread or an operating system process. And in rack, the SMON process of one instance can perform instance recovery for other instance that have failed. So that is the additional things in rack actually. And also it maintains the system chain number, data dictionary, undo segment like that. Okay, clear? Now DBWN, or you can say DBW, okay, database writer process. So tell me how many minimum DBW we had and how many maximum we had DBW, database writer process in our Oracle database. Tell me, guys. Those who attended morning session, please don't reply because we already discussed today in morning session. Please join on time actually, guys. Still people are coming and joining. Almost half an hour past 8. Okay. Minimum 1, maximum 90. Okay. Minimum is correct. 1. Minimum is 1. Okay. But how many maximum? Maximum is 100, guys. So as you can see in my diagram, DBWN. Okay, so it start from DBW 0 to 9 and A to Z, and then naming will change BW36 to BW99. So this is the naming convention when you enable 100 DBW or database writer process in your database. So don't get confused if you are getting BW36. Okay, so that's why I have posted this diagram in my notepad. Clear, guys? Any confusion about naming? So 0 to 9 it's 10, A to Z it's 26, right? So 36 then or 35 whatever, and then 36 to 99, so total 100. Clear, guys? Now, what is the work of DBWR? So DBWR actually write the dirty buffer to the database in the data file from the database buffer cache to the data file. So what is dirty buffer contains? Dirty buffer contains actually new value. So whenever user is updating any record, server process take the block from the data file, and after that server process stores the old value in another block in the database buffer cache, and then it will update new value, and that new value buffer is called as dirty buffer. So new value should be written to the data file, so that work will done by dbw writer process. Clear, guys? So how DBW writes actually? So whenever a server process is not finding any space in the database buffer cache, then it will signal to the DBW to write the dirty buffer. Then DBW write dirty buffer to disk asynchronously. But DBW actually checks one list in the database actually. So what was that list name? Yesterday we discussed that list name, if you remember. Yeah, correct, Azhar. But what my mention in my diagram, I'm asking that name. Checkpoint queue, guys. Please revise the session, otherwise you will not understand architecture. Never, never. Okay. And I'm trying to cover everything in the architecture. That's why I am taking time. Today's second session and most probably third session is also I will take, or fourth session. So almost in four session I will try to complete all the database architecture components. Okay, so that's why I'm doing efforts. So please guys, you can also do some efforts. At least you can revise and answer me when I'm asking you guys. Okay, so now second condition, when checkpoint happens, then DBWR writes actually. So in most cases, DBWR writes are scattered throughout the disk. Okay, so so that's why writes tend to be slower than the sequential write actually. So sequential write, DBWR actually not perform. It is performed by LGWR. Okay. So DBW performs multiple block writes when possible to improve performance, and the number of blocks written in multi-block write varies basically on operating system. Okay, so you can, when you study performance tuning, so when you will tune DBW, so there you will get the things actually. And what is the parameter for DBWR to increase the number and all? Anyone guess what is the parameter? How you will increase? So there is some parameter, right, should be there in the database. So what is that parameter? DB underscore writer underscore processes. That is the parameter actually which you can increase from 1 to 100. Okay. So the first 36 DBWR process name will be DBW0 to 9 and DBWA to Z. And from 37 onward, your naming will be BW36 and BW99 up to. Okay. Clear, guys? And now, yes. Okay, then log writer. Okay, so CKPT I am skipping and log writer I am moving ahead. Okay, so let me take this after DBWR. Okay, so then it will be perfect. Okay, so LGWR. So LGWR is basically log writer process, and LGWR is also a background process which writes the redo entries which is stored in the redo log buffer, and from redo log buffer it will writes to the redo log file group. And we know that we had in every group we have one redo log file, and LGWR handles the operation that are very fast and it has log writer worker helper process, that is LGNN. So that could benefit from concurrent operation, primarily writing the redo from the redo log buffer to the redo log file and posting the completed write to the foreground process that is waiting. Foreground process means server process, and redo transport slave process, that is TT00 dash ZZ, actually ships redo from current online and standby redo log to remote standby destination configuration for asynchronous redo transport. Okay, so LGWR can run as a thread and as operating system also, and LGWR can run on ASM instance also, and as you know that in rack we had separate set of redo log files, so there also it work actually. Okay, so that is LGWR. So when LGWR writes, when user commit a transaction, when log switch occur. So when log switch occur, whenever redo log file is full, log writer will move to another redo log file. So that phase is called as log switch. So we can manually also do the log switch, and internally also it happens when redo log file get full. Okay, and 3 second after 3 second pass, LGWR writes actually, and when redo log buffer is one third full, then LGWR write. When redo log buffer contains 1 MB of data, then it will write. When DBWR must write modify buffer to disk. Okay, so before DBW can write a dirty buffer, the database must write to disk the redo record associated with the changes to the buffer. Okay, so if DBWR discovered that some redo records have not been written, then it will signal to LGWR to write the record to the disk and waits for LGWR to complete before writing the data buffer to disk. Okay, so please remember this point. Okay, so Oracle database can use a fast commit mechanism to improve performance for committed transaction. So whenever user a commit a statement, the transaction is assigned a system chain number that is called as SCN. So what is SCN number, guys? What is SCN number? Checkpoint system chain number. I'm not asking the full form there. And right to checkpoint for every commit there will be a CN system chain number for log light. Oh my dear, there. See guys, a CN is just like a database clock. So whenever your watch, hand watch, sorry, or wall watch actually. So whatever watch you have, it pass like tick 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 like that, right? So second needle, and then minute comes, then hour comes. So in this chain it works. Okay, so whenever you are using Oracle database, so every time SCN number is generated. Okay, so that is SCN number. So you can say it is a database clock. And what is the use of SCN number? Basically to identify the recovery process where you will start the recovery. So whenever user commit a transaction, the SCN number of that actually written by the LGWR in redo log buffer. So LGWR puts basically a commit record in the redo buffer and write it to the disk immediately along with the commit SCN and the transaction redo entry. Clear? And redo log buffer is actually a circular buffer. So whenever LGWR writes redo from the redo log buffer to the online redo log file, so which process actually writes in the redo log buffer? Another question. because redo entry is generated. So which process will write in redo entries in the redo log buffer? LGWR. LGWR writes in the redo log file, not redo log buffer. Okay. Answer me, guys. I want answer from everyone. Those who are fresher, please excuse. Amit is correct. Only two people reply. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people we have. Ishaq, okay. Azhar, okay. Okay, server, okay. You are in morning, right, Lakshmi? Yeah, server process. Okay, so server process is basically write the redo entries in the redo log buffer. Okay, and LGWR normally write fast enough, ensure that the space should be available for server process. Otherwise, server process will wait and your database transaction will wait. So that's why LGWR is faster. Okay, clear? So whenever activity is high, LGWR can use group commits actually. So a user commit causing LGWR to write the transactions redo entry to disk, and during this write other user commit. So LGWR cannot write to disk to commit these transaction unless or until it's previously write complete. So upon completion, LGWR can write the list of redo entries of waiting transaction in one operation. So in this way, database minimize disk IO and maximize performance. If commits request continue at a high rate, then every write by LGWR can contain multiple commit records. Okay, so LGWR writes synchronously to the active mirror group of online redo log files. Remember this point. Interviewer can ask, but maybe interviewer cannot ask. But generally, I ask actually in my when I'm on taking an interview. These are minor things actually because people don't know this also. Okay, so if log file is inaccessible, then LGWR continue writing to other files in the groups and writes an error to the LGWR trace file and as well as alert log file also. If all files in group are damaged or if the group is unavailable because it has not been archived, then LGWR cannot continue to function. Okay, clear guys? And LGWR is also run as a thread and operating system process. Clear guys? Now come to CKPT. So now tell me what is checkpoint, what is the purpose of checkpoint in the database? Yeah guys, why it is called online means भैया क्वेश्चन तो पूरा लिखा करो. जिसने पूछा है भाई उसी से पूछो. उसके आपके नेमिंग में ही आंसर छुपा है भाई. ठीक है. Yeah, tell me what is checkpoint? Updating file header in the database data file. You are telling the work actually, CKPT work actually. I am asking what is checkpoint. I'm not asking what CKPT do actually. because you are answering the work of CKPT. I am asking what is checkpoint. Those who attended morning session, please don't answer. No one is answering. Okay, I will answer. See, checkpoint is a mechanism in the database. Suppose your instance fail. Okay, so from where you will start the recovery? How internal process knows that instance recovery at which point we should start? Instance recovery or recovery means we want to write the data which we lost actually. Okay, data means the buffers, dirty buffers you can say, that was not present in the data file, but it was present in the buffer cache, but due to failure it flushed, right? So CKPT or sorry, checkpoint is a mechanism which actually happen when you do database consistent shutdown, instance recovery, and Oracle database operation actually. So checkpoint basically indicate a position. Okay, that another term comes checkpoint position. So checkpoint position is a place from where instance recovery performed by SMON. So whatever the dirty buffer after that checkpoint position, it will return to the data file, or it will recover from the backup or whatever we have. So actually how it will identify, so the SCN actually plays an important role in that. So checkpoint position is determined by the oldest dirty buffer in the database buffer cache, which was not written to the data file, correct? So checkpoint position act as a pointer to the redo data and is stored in the control file and each data file header. So this information written by the CKPT. Clear guys? So CKPT process is responsible for writing checkpoints to the data file header and control file. And checkpoint can occur in various situations. And what is the purpose of checkpoint? As I said, Oracle database uses checkpoint to reduce the time required for recovery when instance fail or media failure happen, and ensures that database regularly writes dirty buffer in the database buffer cache to the disk, and it also ensures that database writes all committed data during a consistent shutdown. Got it guys? Now checkpoint is clear, checkpoint position is clear. Okay, now CKPT work is clear. Now tell me how many types of checkpoint we have in our database. Types of checkpoint. What is the one line answer for what is CKPT process? See, if you want to give one line answer, so CKPT is a background process. Okay, it will write the checkpoint records to the data file header as well as control file. Okay, so you can answer like this. Yeah, I'm giving answer. So three types of checkpoint we have. One is full checkpoint, one is partial checkpoint, one is incremental checkpoint. So full checkpoint happens when you consistently uh, shut down the database, like shutdown immediate, shutdown transactional. So these are the three shutdown mode. When you do that, then full checkpoint will happen. And in full checkpoint, whatever the dirty buffers in the database buffer cache, it will return to the data file, correct? And you can manually also do the full checkpoint when you fire alter system checkpoint command. And when you do so these are the things when full checkpoint happens. And when you do partial checkpoint, so partial checkpoint is related to any table space, any data file. Suppose you are taking any table space offline, so whatever the data file dirty buffer belongs to that table space, it should be returned before taking offline. Or if you are taking data file offline, so whatever dirty buffer related to that data file, it should be returned to the data file. So that's why it is called as partial checkpoint. Am I correct? And also if you are firing alter database begin backup command, so whatever the dirty buffer belongs to that table space, that will return. And also when you shrinking a data file, on that time also this partial checkpoint happens. Okay, and now incremental checkpoint happen every 3 seconds, and there is a parameter for that. So what is the parameter for that? Anyone? Incremental checkpoint, I said it depends on one parameter, that is empty, fast start mttr target. Okay, this is the parameter will actually decide the value of incremental checkpoint. So by default, I think 3 second actually. Okay, or you can make it up to 300 second. So by default, I think it's zero. Let me check actually. Yeah, by default value is zero. By alter system command, you can change the value, and the value will be 0 to 3600 seconds actually. Okay, so that is three types of checkpoint. And yeah, one line answer for CKPT I'm posting for you guys. So the checkpoint process update the control file and data file header with checkpoint information and signal DBWR to write blocks to disk. Okay, so this is the work of actually CKPT. So checkpoint information include the checkpoint position, SCN, and location in online redo log file to begin recovery actually. Clear, guys? And CKPT can run as a thread and operating system, and CKPT also run on ASM instance. Okay, clear, guys? Log writer checkpoint, is it also available? Log writer checkpoint, I never heard this type of word actually. I will check and let you know, guys. Yeah, so that's it for today actually. Too much I'm speaking actually. So I'm stopping here. Okay, so if you have any questions, then you can ask actually. learn many things. Thank you, sir. Okay, that is my aim actually, to help you guys in database career. So that's why I'm giving this free workshop to everyone for old architecture. If you know old architecture better, then you can understand new architecture, which is CDB, PDB, or you can say multi-tenant, or you can say container or pluggable database. So that we will start after this workshop. Oh my God, Rajiv, I also told that this performance tuning, I'm not discussing, my dear, here. Okay, so I will not cover performance tuning questions here actually.